We're in the studio with the band Science Dragons as they record their new single, Lightning.
Thunder and lightning. Wait, guys. As we're jamming, I just realized I don't even know what lightning is, man. Yeah, man. Tell you the truth, I don't even know what thunder is, bro.
Liftoff. That's one small step for man, one giant leap for mankind.
What the f*** are lightning and a thunder? Lightning is a sudden electrical discharge between two charged objects. Simply put, one object builds up a positive charge while the other object builds up a negative charge. The charges then try to neutralize. If you've ever been static shocked, you've probably experienced something similar to this yourself. In the skies, this can happen in a number of different ways. It can happen between differently charged regions of the same cloud, between two individual clouds, or the most familiar to us, between the clouds and the ground.
Factual combat. Science versus ignorance. Round 1. Fight.
Lightning can strike in the same place twice. The Empire State Building, for example, gets hit all the time. A lightning bolt travels at nearly 60 miles per second. Lightning isn't caused by god farts in the sky.
I'm not worthy.
During a thunderstorm, small ice crystals and soft hail move around in the clouds. The ice crystals are light and are pushed upwards by warm air currents, and gravity pulls the heavy hail down. Their different paths cause friction and collisions between the ice and the hail to occur. The ice crystals going upwards become positively charged, and the hail going the other direction becomes negatively charged. This results in a difference in charge or polarization. The top of the cloud becomes positively charged, and the bottom becomes negatively charged. This has an equally important effect on the surface of the Earth. Because like charges repel each other, like negative charge repels negative charge, and positive charge repels positive charge, the negative buildup on the bottom of the clouds repulses the negative charges away on the surface of the Earth. This creates an overall positive charge building up on the ground. The air between the cloud and the ground acts as an insulator, and it keeps the lightning at bay. Just like the rubber around electrical wiring, it prevents the flow of electrons, but it can only defend against so much. As the difference in charges starts to build up, a lightning strike becomes imminent. The strong charge sheds the electrons from nearby gas molecules and transforms the nearby air into plasma, a fourth state of matter, which is highly conductive. This makes for faster travel from the cloud to the ground. It basically makes itself a highway from the cloud to the ground. The negative electrons on the bottom of the cloud then rush towards the surface of the Earth. The path they make looks kind of like a stepladder. Although the reasoning for the stepladder is not completely understood, it's theorized that the stepladder is created because of dust and other particles in the air that alter the conductivity of the air. You see, electrons are kind of like humans, very lazy. They want to get to the surface by following the path of least resistance. It's thought their changing to an easier path is the stepladder that we see. Sometimes two of these ladders can meet in the middle, one originating from the sky and another one originating from the ground. Once contact has been made between the Earth and the clouds, more than 1 billion trillion electrons take this path at more than 50,000 miles per second. This enormous and rapid flow of charge quickly heats the surrounding air to nearly 30,000 degrees Celsius or 54,000 degrees Fahrenheit. This causes the surrounding air to violently expand. This violent expansion creates a shockwave that we hear as thunder.
Round 2. Fight.
On Earth, lightning strikes 40 to 50 times a second, or 1.4 billion times a year. The lightning that we see travels to our eyes at 300,000 meters per second, or the speed of light, while the thunder travels at 300 meters per second, the speed of sound. This is why we see lightning before we hear the thunder. The phenomenon known as lightning isn't found just on Earth. It's a much more common occurrence on other planets in our solar system, like Jupiter and Saturn.
Science wins. Flawless victory.
Now you know what lightning and thunder are.
Yo, man, Science Dragons here again. Just want to make sure you subscribe and like us on Facebook and follow us on Twitter, man. We post some pretty rad daily content that you should check out, like Picture Monday, Trivia Tuesday, Wild Wednesday, Throwback Thursday, and Factual Friday. Back to jamming.